So we're going to do some different properties of functions, increasing and decreasing intervals, finding maxes and mins, identifying whether it's even or odd, and then we're going to talk about the rate of change, the average rate of change of a function. Okay? So here we go. Increasing, decreasing, constant. So when a function's height, or y value, is increasing, it's going up, or it's rising from left to right. If it's decreasing, it's falling from left to right. If it's constant, it's staying horizontal. Okay? The key to this is you are talking about x intervals. From what x to what x is the graph going up? We know the y is increasing, but we want to know what x values are the interval that it's increasing. From what x to what x is it decreasing? From what x to what x is it constant? We do not want the y's. We want to know from what x to what x. Okay? I know you're going to be able to tell whether it's going up or down or staying constant. But we want to be able to see that. All right? So we've got this guy. So do you guys see where it's decreasing, constant, and increasing? Do you think you have it in your head? Are you right? Is that where you talk about? This first section's decreasing, the second section's constant, third section's decreasing, fourth section is increasing. So if I'm going to write those as intervals, we are decreasing first. I just go in order, so it's up to you how you write these. On the test for Math Excel, it's just going to say what intervals are. There's a bunch of decreasing or whatever. So it's decreasing first. So from what x to what x is it decreasing? -5 to -2. We don't care that it's going from 7 to 4. We want to know what x values. Then it goes constant, yes? From what x to what x is it constant? -2 to 0. Then what does it do? Decreasing again, so we're going to union. 0 to 2. And then finally it gets to increase from 2 to infinity. So if you look at this, you can put these in order. So -5 to -2, 2 to 0, 0 to 2, 2 to infinity. You should have them all in a line, right? The entire domain, -5 to infinity. If you put them in order, understand what I'm saying? So if I were to put those in order, I'm decreasing, then I'm staying constant, then I'm decreasing, then I'm increasing. So if you look at all those intervals, you are from -5 to infinity. Right? It includes everything. Now, here's my question. Somebody had a question earlier this lesson today. Why aren't they squared brackets? Would it be wrong to put them as square brackets? Because they're closed intervals. They're closed points. Okay? So really and truly, it is a matter of who writes the textbook. Some textbooks, you're going to see those as square brackets. Some texts, you're going to see them as curved brackets. I personally agree with the curved brackets because if I'm sitting here at x equals 2, I am neither increasing nor decreasing. I am turning around at that point, yes? So our textbook is curved brackets. So don't use square brackets, okay? But in another math course, you might see square brackets. It's not that it's wrong, it's just a different way of thinking of it, okay? All right. Here you go. So take a minute with your buddy and see if you can find increasing, decreasing, or constant intervals. So we're going to start drawing it this way. So we are starting at decreasing, yes? From what to what do we have here? -infinity to -7. Perfect. Now this next set is increasing. Do you see that there's 1, 2, 3, 4 little sections that are all increasing? Can you lump them all together? Yes. Okay, so we're just going to put those all together in one interval, -7 to +3. Because really, you're still going up the hill. You're just stopping, right? At a rest area or whatever. Constant from 3 to 7. And then we go back to decreasing. So you need to put a union. Anytime you have more than one answer per, or more than one interval per type, you're going to union it. So that's 7 to infinity. Okay? You do okay on that? Remember, you're drawing from left to right. All right, moving on. Absolute extrema, guys, we're talking maxes and mins. Where is the graph turning around? Okay, so they're called relative extremes because it depends on the window. So if I'm looking at the entire function here, this point here is the max of that function. Nothing's going to go higher, correct? But if I'm going to look at this window, between those two lines, do you see another max? Do you see the whole top between those two lines? Yeah. So this would be a relative or a local max relative to the window that you're looking at. Does that make sense? So every turnaround point, every max, every min, hilltop value, you're going to write as relative. Okay? So same thing. Even though this function is continuing down, the lowest it goes is in negative infinity, this guy within that window is a minimum. Okay? If you want to get crazy technical, and I don't want to get too crazy, if I'm looking at that window, do you see a max? Even though it's not a turnaround point, do you see a max value? In that window, this would be a max, right? And this would be a min. So it all depends on the window that you're looking at. So we call them relative maxes and mins when we're talking any hilltop and valley. Any turnaround spot is a relative max or min. Okay? Any turnaround spot. All right. So here, give me a min. I'm going to start from the left. What's the first min you see? This guy here, right? Which is -3, -2 as a coordinate. Okay. This turnaround spot is -1, 2. Good. Next one's going to be. Okay, so we could find those. That's not hard. You're looking for turnaround points, lows and highs. The one right next to it, the one above, we're fine. The one next to it, we have a set that's constant, yes? Is that a max or a min? Again, depends on the window. So if I'm looking here to here, those points, all of these points are a min. But if I'm looking, here to here, they are a max. So if you have a constant interval, you're going to write it that it is extreme values. You're not going to label them maxes or mins. You're going to say there are extreme values of any point from x to -4x. Move that. Where the graph is from -4 to 3. So x to 4, x comma 4, on the interval -4 to 3. So you're just going to say them extreme values. Okay? All right. Other than that, it's turnaround points, or if they're giving you a specific window. So, using your calculators, I would like you to graph -2x cubed plus 3x squared. Okay. So we have a graph like that. We're going to go in standard window. All right. So do you see that you have a low and a high turnaround point? Okay. So this is how you need to do it in this class. Some Algebra 2 teachers hopefully showed you this way. You're going to hit second trace, which is your calc button. See how it says calc in blue? And you want to pick the minimum. Now, the left bound, right bound is asking you what window do you want to look at. So I want to be left of this low point. So you have two choices. You can arrow left until the little blinky guy is to the left. Okay, so he's to the left of the low point, yes? You hit enter. Then it's saying right bound. You can arrow right until he's around the corner. You don't want to go too far right, though, because you might be down the hill on the other side. So he's right, hit enter. Notice it gives you the little window boundaries with the vertical lines. Hit enter again. Okay. So I'm going to blow this up so you can kind of see it. Does anybody have an answer that's different than mine? There should be some. Okay? This is good. That's the whole point. That's why I wanted you to do it. What does this x value state? What does this equal? Negative 1.64? Keep reading. 1e to the negative 6. What does e to the negative 6 equal? What does that mean in your calculator when you have that e? Times 10 to the negative 6 power, right? Which means if I'm going to write this as a decimal, whether it's positive or negative, what does that round to? What would I round that to? 0, right? Does everybody's x round to 0? And everybody's y also rounds to 0. Do not just look at the numbers and start writing answers down. Look at the graph. Couldn't you tell that that was at the origin? Your calculators are a little bit different than mine because there's a tolerance level. And that's okay. They should round to the same. So when you see e to the negative 4 or higher or whatever, you're going to say that's 0. So this min is at 0, 0 as a coordinate. Okay? So just be cautious of that. Go back in, and you want to go to second calc max. Left bound, I'm just going to leave it there. Right bound, let's pick an x value. Give me any x that's on the right side here that's going to be on the right side of that max. You can just type in the number and hit enter. It'll just jump that way. Okay? Enter one more time through the guess. What does that round to? 0, I'm sorry, 1, 1, yes? Okay. So this is 0, 0. This is 1, 1. I understand sometimes they won't want you to write it as a coordinate. The min point here is actually 0. When they ask for what is the minimum value or what is the maximum value, they want the y value. If they want the coordinate, they're going to ask you for the coordinate. If they just ask you what the max value is, you're going to say it's 1. Max value or min value here is 0. When x equals a certain value. This is not a good example because they're both the same number. All right. Let's continue. Even and odd. We already kind of worked through this before. So it is even if it folds in half symmetric to the y-axis. Remember doing this last week? Symmetry? So algebraically, f of negative x equals f of x. If you plug in a negative x, you're going to get the same exact equation as you started with. That's an even function. If it's odd, algebraically it says, if you plug in a negative x, you will get the opposite function because the y part is also negative. Okay? So if it's even, when you plug in a negative x, you get the exact same thing. It's equal to the original function. If it's odd, it's going to be opposite of the original function. When I plug in a negative x, and I make this side, this y, this f of x negative, they should be the same. Okay? So, you've got to be able to show it algebraically. And also look at a graph and tell me even, odd, or neither. So So if I'm looking at x squared, that's the graph. You see that it folds over the y-axis. Okay? And this is x cubed. It rotates around the origin. All right. Algebraically, though, let's do even. F of x should equal f of negative x if it's even. That's the rule. So I'm plugging in a negative x. You're always plugging in a negative x and seeing what happens. So f of x was x squared. X, or negative x squared, is also x squared. So they're equal, you're done. That's an even function. To prove that it's odd, you're going to say opposite. That's kind of like changing the y value. Do you remember doing that when we're doing symmetry? For rotation around the origin, we change the y and the x. Remember, f of x stands for y. So we're changing the y and the x. So left side is negative x cubed, right side is also negative x cubed. Done. It's odd. Okay. If you distribute the negative, you get back to the original, but still equal. All right. Even odd. Or neither. Remember, these are functions, so we don't have that symmetry over the x-axis because that's not a function. These are all going to be functions. So it's going to be either even, or odd. Understand, if this goes off the y-axis, if I have this guy, is he even? No, it has to be over the y-axis. Has to be. It has to rotate around the origin to be odd. This still has a line of symmetry. It's just not the y-axis. You can still have a point of rotation. It may not be the origin. Okay, so for it to be even, it has to reflect over the y-axis. To be odd, it's got to be around the origin. Rotation. Okay, so determine whether it's even, odd, or neither. So I'm going to make little columns because I figured out last period this is the easy way to do it. Let's do g of x, and let's do negative g of x. So this is testing for even. This is odd. All right. So g of x is just the original equation. Easy enough. Opposite of g of x. When I distribute the negative through, I get that. Okay, so we're going to find both of those. Then we're going to find what does g of negative x equal. So when I plug a negative in, I evaluate that fourth power. Which one does it look like? The even one or the odd one? Which setup does it look like? Even or odd? Even. It matches the original. Does that make sense? So we're going to write both f of x and negative f of x. Figure out what those look like. And then do f of negative x and compare. Okay? Or you can just kind of guess and try it out. I think it's almost easier to do it this way. So, over here, we're going to do even. It's just g of x. Same old that we started with. Odd is the opposite of g of x. You just have to remember you're distributing the negative to the whole function. So if it's even, it's going to equal the top guy. If it's odd, it's going to equal the second guy. Plug in your negative x and compare. Is it even? Is it odd? Is it neither? It's neither, right? It doesn't match exactly for even, it doesn't match exactly for odd. So this is a neither. That's one of those that may have symmetry, but not on the y-axis or not around the origin. Makes sense. Yes? Okay. Now, they get a little bit more complicated. We're going to do the same thing. Same exact thing. So, g of x, I'm not even sure why we're rewriting it because it's sitting there. So this is our even. Odd is negative g of x. Now this is where people get into trouble. I say people, but not you guys. You guys got it going on. Where do I put that negative? Do I distribute it to the top, the bottom, or both? Where would you distribute the negative? Just to the top. We do not distribute it twice, because if you distribute it twice, it cancels to a positive, right? So that's just this guy. You could distribute it to the bottom. I don't know why you would, but you could. Okay? All right. So now we're going to do g of negative x. Okay, and that's what my g of negative x equals. So is this an even function or an odd function or neither? What do you think? Which one does it look like? Odd. Does that make sense? You guys do the next one. See what you get. You might have a little trick. See how good you are. Okay, does everyone have that written? Are we where I am? Okay, so before we start comparing this, because right now it doesn't look even nor does it look odd, right? It doesn't match exactly, but you have to think, can I reduce that? The top looks opposite, and the bottom looks opposite, correct? You see how the top to the original, the top is opposite of the original, the bottom is exactly opposite of the original. I can, when that happens, you can pull a negative out of the front or the top. You can pull a negative out of the bottom to switch those guys back. And what is a negative over a negative? Positive, so that cancels. Now, is this even or odd? Which one does it match? Even. So you have to pay attention to that. Can you reduce things? When things look opposites, you want to be able to switch things, okay? Let's. All right. Average rate of change of a function. This is easy. If I'm looking at 2 points, do you see that this A can be considered a first x? And when you plug A in, you're going to get a y that matches that x. And this B, since it's further down the line, we can say it's x2. And we plug in that B and I get a y2. You see that this formula is just y2 minus y1 over x2 minus x1. It's just the slope formula. Written a little different. Okay? A little fancier, a little higher level thinking. Okay? But it's the same thing. It's the slope formula. So don't let it mess with you. when you have a function that is not a line, slopes are line things, okay? So if it's not a line, you are going to draw what we call a secant line, and you're going to find the slope of the line that connects those 2 points to the function. It's not a constant rate of change. We are calling it an average rate of change between this point and this point. Okay? So let's look at this real quick. This A happens to be 0, -7. This B is 9, and the height there is 3. So if I want to find the average rate of change, it would be the second y minus the first y, or f of b minus f of a, and then b, which was 9, minus 0. So you're just doing the slope formula. Okay? But of course, we're going to jack it up a little bit. Okay. So, find the average rate of change of f of x equals 1 minus x squared as x changes from 2 to 4. So they're not giving you the whole story. They're only giving you the a and the b. So how do I find f of a? How do I find the y that matches that 2? Plug it in. So if I put 2 in for x, I get 1 minus 2 squared, which is -3. Yes? And to find the y that goes with the 4, it's 1 minus 4 squared, which is -15. Good. And then I do my formula. F of b minus f of a over second x minus the first x. So -12 over 2, -6. Easy enough. Okay, let's try this next one. Function is 1 minus x. The two x's they give me are 2 and a. So if I put 2 in, I get 1 minus 2, which is -1. If I put a in, I get 1 minus a, which is just 1 minus a. Okay. And then we're going to do our formula. Second y minus the first y over second x minus the first x. What does minus a negative do? Make that big plus. So up top I have -a plus 2. On the bottom I have a minus 2. Those look like opposites, don't they? So you can do it officially by factoring out a negative from the top. But what does that equal? -1. Think about it if you're dividing opposites. If I divided 7 divided by -7, it would equal -1. If I divide by 3 divided by -3, it would equal -1. They're opposites. But technically what you're doing is dividing out a negative in the numerator. Okay? All right. This next one is really a little bit of introduction to calculus. This is like a starting calculus topic. Okay, we're not going to get too crazy into it, but the difference quotient, same thing. We're finding the rate of change, the average rate of change between 2 points, but we're not going to give you any numbers. We're going to say x and x plus h, which is a certain distance. So for instance, if this x was 3 and this x was 10, what does h equal? If this x is 3 and this x is 10, 7. H is 7. So the h is arbitrary. We don't know how far apart our x's are. But the difference quotient is same thing. F of x plus h just means the second y, the furthest along height, minus the first y. If you do this, the second x is x plus h minus the first x. See how the x's are going to cancel and you have an h? That's where they're getting the h. All right. And you'll kind of see where we're going on the next slide. So I'm not going to give you x plug in, not even one. So we have f of x squared. So the first thing we got to do, you can kind of go to the side if you want. What does f of x plus h equal? So I'm going to plug in x plus h into my function. Remember we did this the other day? And the quicker you can FOIL this out, or just know how to expand it, it's going to be x squared plus 2xh plus h squared. If you need to go and FOIL that to the side, I don't care. But you got to be able to expand that. Okay? So, the rule says you're going to take that, which is this guy. You're going to subtract f of x, which was just x squared, and we're going to divide it all by h. So you're taking f of x, what you get when you plug in x plus h, and this is a very, very basic one, understand, minus the original function, all over h. So what do you notice? What happens here in the next step? The x squares cancel, don't they? It will always happen with the difference quotient that everything that just has an x, it doesn't have an h, should cancel. If it doesn't, you expanded something wrong. So this guy and this guy are gone, and you're left with 2xh plus h squared over h. Now what can you do? Can't I cancel out an h everywhere with every term? So technically, again, what you're doing is you're factoring out an h. But if you can just see that and cancel it, and I'm okay with it, 2x plus h. That's your difference quotient. And what this allows you to do is do a whole bunch of these questions. What's the average rate of change from x being 2 to 11? So what did we have to do? You have to put 2 into the original function. So my x is 2. What's my y? 4. My x is 11. What's my y? 121. Then you have to find the slope, right? 121 minus 4 over 11 minus 2. That's 98. No. 97, right? Divided by 9. Something's wrong. Losing my mind. I'm like, that's not right. 117 divided by 9, which is what? 13? Now, watch this. This is x. This is x plus h, correct? So let's just plug in that. My x is 2. What is my h? 9. What's 4 plus 9? Okay? So it allows you to do that slope thing, that average rate of change, quicker given two x values. All right? And you're thinking to yourself, well, it didn't take me that much longer. I had to write all that out. The higher it goes, the more it is. And again, this goes into calculus when we start talking about derivatives. Okay? So, tomorrow we're going to start with the last example. It may take you a minute or two.